a previous video in this series, we looked at how current behaves in a typical ring final socket circuit. And we saw that when the circuit was loaded up at different points, different amounts of current flowed in each leg of the ring. Now in this video, we'll be looking at how current behaves in a ring final circuit when it's wired in dado trunking. So what I've done here is I've wired up two separate ring final circuits through this dado trunking system. Now this is the Elite Compact range from Atkore, and it's got some absolutely great features that I'll explain in a future video, so keep an eye out for that. The first one I've wired in the following manner. I've taken the first leg out from this rather lovely new consumer unit from PremSpec, from here out to the first socket. And then the second leg goes from the consumer unit out to the far socket, and then each socket in between is connected together to complete the ring. Now before we explain how the second circuit's been wired, let's load up the ring and take some measurements. So I'm going to connect a 4 kilowatt load up to the circuit and measure the current that flows. I'll plug into the nearest socket first, and then we're going to measure that. The sockets that feature in this video, by the way, are from the Verso range from PremSpec, and I'm sure you'll agree that they're great looking and really good quality as well. So let's get measuring the current that flows in each leg. So when I was installing this, I slipped a little bit and accidentally brought the cables out through the lid here. Now I'm not for a moment suggesting that this is the way to install these cables. It just gives me a neat and convenient way to measure the current flowing in the conductors. Now this conductor here goes to the far socket, and this one goes to the closest socket. We've got the load connected. Now I'll measure the current flowing using this Metrel MD9235 clamp meter. And as you can see, we've got going out to the far socket, just bring in meter cam here. So you can see there we've got about 2.8988 amps there. And on this one, you can see we've got about 12.67. So as perhaps you may expect if you've seen the previous video in this series, we've got the bulk of the current flowing through this leg to the nearest socket. But let's look at what happens as we move the load further along the ring. So what we'll do is we'll move the load over to here, and then we're going to measure the current again that's flowing in each leg of the ring. So again, in the far leg, you can see if I bring in meter cam again. So you can see there we've got 4.16 amperes. And then on this one, we're getting somewhere around 11.69 thereabouts. And that makes sense. We're increasing the resistance in this section of the ring and reducing it slightly in this section of the ring. So the current splits accordingly. But let's jump along to the final socket now. In a previous video, we saw that as we connected the load to the socket fed by the other leg of the ring, the majority of the current flowed through that leg as it had the lower resistance going back to the board. So let's power the loads up. So we've got those switched on, and let's measure the current in the legs. So the leg that comes straight from the socket to the consumer unit, which is that one, you can see there now that we've got 7.94 amperes. And in the leg that comes back via all the other sockets, you can see we've got 7.99. So almost exactly the same amount of current in each leg there. So even though we're at the far socket, we've got the current fairly evenly split. Why is that? Well, it's because we're actually roughly at the midpoint of the ring in that socket, electrically speaking. The conductor from there straight back to the consumer unit is roughly the same length as the conductor that goes from there to each socket and then back to the consumer unit, which means that the conductor resistance is roughly the same from here to the consumer unit along both those return paths. So what does this show us? Well, it shows us that it doesn't matter where we connect our load along here, we're almost always going to be drawing the vast amount of current down this leg. In other words, it's very hard to balance the legs in dado trunking when the ring final circuit is wired like this. In fact, the only time that's really going to happen is when we only connect one load to the end socket there. Is that a massive problem? Well, Appendix 15 of BS 7671 provides some interesting information on the subject, where it outlines the conditions for a reliable and safe ring final circuit. The very first point suggests that socket outlets need to be located to provide reasonable sharing of the load around the ring. So how can we achieve this for a ring final circuit in dado trunking? Well, one of the key points is to try and keep the legs of the ring the same length. So if we bring the first leg of the ring to this socket, then we bring the other leg of the ring to this socket, and that makes them roughly the same length. Then we use the hit and miss method. We take a conductor from this socket over to this one, and then we take a conductor from this socket to this one, from here to here, hitting and missing every time, and then we just join up the last two sockets on the circuit. Now, at this point, let's make it very clear, this method of wiring up the ring circuit here won't perfectly balance the legs of the ring all the time. However, it turns the ring from being pretty much guaranteed not to have the same amount of current in each leg to giving you a fighting chance to do so. Let's demonstrate. So I'll plug into the first socket and measure the current. So we'll do that now. So I'll bring this over here, plug those in there and measure the current in each leg of the ring. So in this case, this leg goes to this socket and this leg goes to this socket. So let's measure those currents and see what we're getting. So you can see there that in this leg we are getting via meter cam 12.25 amperes there, and in the other leg we've got 3.64 amps. Now if we move the load to our second socket on our ring final circuit, if we did that on the circuit above, we'd expect the current just to even out a little bit, wouldn't we? Even though we saw that we'd never get the other leg using its full capacity, we wouldn't even come close to that. But what happens in this circuit? Well, let's measure it up. So once again, you can see now that in the leg that goes to this socket here, we're getting 4.34 amps. And in this one that goes to the second socket there, we've got 11.65. So the current is now being drawn mainly through the other leg of the ring. So what does that allow us to do? Well, if I plug one load in here and one load in here like this, and then we'll measure the current in the two legs again. So let's connect up there and measure that leg. You can see there we're getting 8.4 amps. And in this one, we're getting 7.72 amperes. So you can see from that, we're actually in a position where we can plug loads into different sockets and stand a chance of actually balancing the current in each leg of the ring. Now in reality, of course, we can't always tell what's going to be plugged in where, and there's never a guarantee that the legs of the ring will be perfectly balanced. And indeed, the very nature of a ring final circuit means that it doesn't have to be perfectly balanced all the time. But by wiring your circuits in dado trunking in a fashion like this, you've given the legs a fighting chance of being balanced, and actually you've shown your commitment to complying with BS 7671 as much as possible. But of course, as always, we want to hear from you. Is this how you connect ring final circuits in dado trunking, or do you do it another way? Do you have any other hints, tricks or best practices for installing ring final circuits in dado trunking? Or do you think that maybe this is just another sign that the ring final circuit has had its day and it's time to retire it to the history of electrical curiosities, along with lead sheath cables and wooden fuse boards? Whatever your thoughts, please leave them in the comments below and be sure to check out our other videos on dado trunking. All that remains in this video is to say thank you very much for watching.